Howdy, everybody. Welcome to the pre-show. Now we have a pre-show 5 minutes ahead of time. So if you want to skip this part, just skip 5 minutes ahead. If not, you'll hear to admire what I do on my screen from now until 5 minutes later. So okay. Is this one recorded? I think that's the right one. Yep, that's the right one. Okay. Let me put it on top. And then I will put it like that so it's easier to see. This one. That's good. Yeah. Oh, howdy. Sorry. I'm just looking around. Howdy, how is everyone doing? Good. I'm doing well. I yeah, just enjoying my Sunday doing nothing. Mhm. Let's see. We can start in a minute. I will check and make sure it is recording. Please, when you go and watch this, please skip the first 5 minutes because I just turn on, make sure I don't turn it off. So you might see like me doing random stuff for the first 5 minutes, but after that, that should be fine. Make sure I have the code ready. Everything is ready. So nothing much happened today. I still don't know what I'm gonna do for the review, which you have a test in about 2 weeks, 3 weeks. So I'm still like thinking what exactly I can do. Probably if he has a review, I can go over that. If not, I guess I would just take questions for that day. I don't have anything prepared yet. I didn't really look at the lectures or anything. I really don't have much time for that. So, but I can try to answer a question. Of course, there's Ross right here as well. We can answer a lot of questions about that. Can also ask for, I would say from my feedback from previous semester, his test is pretty fair and it's pretty straightforward. So I hope that you guys will do just fine on those. So, all right, actually we can start right now. Let me share screen. I mean, let me put on the thing. Oh, display. Switch. There you go. So everyone can see this, right? Okay, awesome. Okay. So howdy. We're back with this week is Stack Overflow edition because we're gonna get some inspiration from Stack Overflow in a bit, but so that's basically this meme is about is as a programmer you might take some code from Stack Overflow, but you should try to understand it because it's okay. I mean we take codes all the time, so it's okay. As long as you don't copy your friend's code or anything like that, you can take some inspiration from Stack Overflow. So any question I can start with? Oh, no question. Okay. So for next week, again, you have PA2 due on February 24th. So if you haven't done it, no, well, it's good time to start. Don't be like last minute. Last time in PA1, there's student who asked where's their starter code 2 days before it's due. Please don't do that. Do it early. And also, I just want to remind you that if you're confused about something, most of the question can be answered. You look at the instruction carefully and you look at the slides, the videos, the tutorials posted on Canvas, or the slides that I post every week. So please look at them and before you ask questions, because a lot of the question can be clarified that way. So we're back with the shell. So let's go to the shell. So as a reminder for last week we talked about all the basic commands, all the checkpoints for PA2. So basic command, we talk about basic redirection commands. So all these, that should be pretty straightforward. We also talk about CD last week. I also talk about background command and there's a student who asked me about re-implement. Maybe they weren't here last week, or maybe I didn't record it and the background process one wasn't clear enough. So after this presentation, I will try to also answer that as well. But we're almost done. That's about it. So we only have pipe left to talk about. So what is a pipe? Well, pipe in here is the same as FIFO pipe. In this case, it would be unnamed instead of named. So it would be a very arbitrary part of the pipe that you will have to do. It's like shared memory kind of thing. So if you remind yourself a little bit that FIFO pipe, you have a pipe right here that you talk to from the server, you have read-only side and write-only side, write-only side, read-only side, and you go around like this. You have two pipes for duplex communication like this. Then the idea of an unnamed pipe is pretty much the same, is that it has a read side and a write side, and you have like a array of 2 file descriptor, and then you plug it into the pipe and it will return a read side, a write side, a read side. If you're new to this, and if this is your first time using it, it might be a little bit confused that the right side would be FD1 and the read side would be FD0. But if you think about it a little bit carefully, you know that STD out is 1 and STD in is 0. So you read the process. So if you have 2 process, the STD out of the process will be plugged into the right side, and the STD in of the other process will be plugged into the read side. So it's kind of makes sense, especially if I have this one right here, is that, you know, you have 2 process, and I will talk a little about this. Is a little bit miswritten. It's actually just the P1 STD in and P2 STD out, and not related to the parent. So that's my bad, but I just show you right now, is that if you have STD in and then STD out right here, this one should be 1, right? In is 0, out is 1. So then that's plugged into FD1, and then FD0 here will be plugged into process to STD in, which is 0. So that's how I remember. So this is basically the essence of the terminal pipe processes. So let's talk about it. So in this, and today I will actually show you what I implement, the way I implemented, and I actually took some inspiration from a Stack Overflow post, which I did not credit for some reason. I will show it in a bit, but that one is very concise, and it makes a lot of sense, and that's what I use for my old one and this one. So in this case, we have 2 functions, which I will show in a bit. So make a separate function. It's called from main when tokenizer per object size is greater than 1. So the way my brain works is that I have a basic command processor. So if you just have one process, one command, then it will go to a separate one that deal with all the intricate, the small stuff like CD and stuff. But if you have more than one, so then I will put it in a pipe process function. So a function that spawns, so inside that pipe process function, we'll have a function that spawn processes and connects the inputs and output of a process to the correct file descriptors. So maybe it connect to IO redirection, it will connect to standard in and standard out, or it will connect to pipes, so which we'll see in a bit. And then a loop that continuously construct processes for all commands, create pipes, and fills the parameters of the spawn process function. So that's basically what it is. So so here's the structure that I was talking about, is that, so this is inside the main function. So inside the main, if tokenizer commands.size is less than 2, then I put it in a single command processor right here. And then else I will put in a process pipe tokenizer. Of course, your might be different, and that's completely fine. It's just that this is the way I think about it, and it's just easier to do things. So inside that process pipe will be a loop, and inside of that loop will be a spawn process. So the spawn a process for the current stage of the pipeline, with the in pipe set to the previous iteration, and the out is assigned from the conditional block above, which I will show you in a bit what it looks like. Well, I don't show you the code, but I will show you the concept. So let's talk about details. So what should go inside the loop? Again, the process pipe will contain a loop and some variable outside of the loop. So you need 3 variable outside the loop, which is in, out, and file descriptor, right? Because you have file descriptor. I put it outside so that it's a little bit clearer. And because the in file descriptor, the first in file descriptor will always be standard in. So I put it outside the for loop. So what should go inside a loop? Well, you create a pipe, right? And before you plug in the values of the into the spawn process function, which is this one right here, you can see it has 3 parameters: the the input, output, and the tokenizer command, like the current command that you're doing the process. So before plugging in the value into the spawn process function, we should check whether, I don't know why, whether this command is the last command or contains IO output redirection. So if it's the last command, then or if it's IO redirection, then you don't plug it into the new pipe. You don't plug into the pipe we just created. We just plug straight it into either the file descriptor, the file you open, or to the standard output, right? So at the beginning of the loop, you have to make sure that the output is different. And if it's last command, if it's the last command and does not contain IO output redirection, then out equal 1, right? Because out would go to the standard output. Else, if else, plug the values into the spawn process function. In the initial loop, n will equal to 0, right? Because the first process or the first command will be plugged from the standard input of the parent, or of its own standard input. The parent one, I'm sorry, I mistyped that. I will remove that and re-update the presentation. And once the spawn process function is called, we close the right side of the pipe, because once we call the process function, the process is, the command is already executed, so we don't need to write to the pipe anymore, and you have to close it, because else it will stall and waiting for more thing to input to the pipe. So you have to close it once you call the spawn process function, and then n equal to fd0. So in this case, the input for the next iteration. So now you're done with the process, you go and you assign n equal to fd0 as the next process reads from the read side of the current pipe, so that you iterate again, and then it would read from the current pipe that you just wrote into, and then we repeat the process. So in this case, that once you're done with right end of the pipe, the child already wrote here, prevent stall by closing it. So you close it. If out, it's not standard output, then you close out, right? Because if it's not equal to 1, that means it is part of the pipe. And then the next process should get its input from the right end of the pipe. So you go through, this is literally the structure of the loop. You do all of this, and then at the end, you repeat the process, you go loop up again. Yep. Does that make sense? No question? Okay, I hope it makes sense. So let's go inside the spawn process function. Well, inside the spawn process function, you would fork the child, of course. And in the child process, we check if the current command has input. If it has, we do dupe to like single command. So remember how you do IO redirection last week? You do the exact same thing in the child process, right? Because it doesn't really change. You still have the input. If it doesn't, we check if the in parameter is 0, right? Is 0. If it is parent, again, it is the current child, it's the child STD and not the parents. I need to update this. If it is not, then we do the child STD into the in parameter value, the output of the pipe created from previous iteration, right? So if it is not, then we just move the input. It's from the previous pipe that you go in, and I will have an example in a bit that show it in more clear details. But basically, you plug the pipe, the read pipe of the previous pipe to this current one, so that you can get the message from the previous process. Then we do the same thing for the output process. So check if it has output. If you do, then you do the standard IO redirection, and then the out parameter. If the out parameter, again, if the out parameter is not 1, right? If the out parameter is not the standard out, then you plug it into the output, the right side of the pipe that you just created, and that is how you write to the next pipe, and then the pipe will hold the information until the next process created and and it's connected to the pipe. So I assume that we don't combine pipe and background processes together. So in the parent, we just do a standard wait PID to guarantee the order. So you just wait. So I have exec VP right here in the child, and then in the parent, I just do wait PID, no PTR, and that should guarantee the order of the process. So any questions so far? Is it clear? Like, I hope it is. Okay. Okay, that's good. So now let's do an example. So an example with some MS Paint. So in this case, you have ls, al, grep command, and then translate it from, so basically it will ls, al, and then it will just command everything and then translate everything to capitalized. So we need 2 pipe for 3 processes, right? Because you connect three of them in the middle. So assume that pipe 1, so FD0, so the right side is 4 and the read side is 3. And then the right side of pipe 2 will be 6 and 5. And I will show you right now how it looks like. So with ls, al, right, in would equal to 0. It would be, it's always started with 0, standard in, right? Even if ls, al doesn't really get anything from the standard input, you should always do that so that, you know, if something does, then it can get from standard input. And then the out would equal assigned to 3, right? Because the right side, it would output to the right side of the pipe. It write to the pipe contain all the information, the output in here, and it's now waiting for the next pipe to connect to the 4 so that it can output to the other side. And then CMD will be equal to LSAL. So then you create, so the next loop, so this is the first loop. The second loop, it will go to in equal to 4, right? Because to the previous pipe, all right, the previous pipe, and then output would be equal to newly create pipe. And then the command would be grep command right here. And then you do one more time, you loop again. So now it would become the read end of the previous pipe, again, FD1, in equal FD1, then you go up again, and out would just be equal to 1, right? Because it's the last, we check, this is the last command that we have to execute, and then it would output the STD out. And that's it. And I said, I will clarify that it took me a while to understand this. It took me last year like 1 to 2 hours, and I have to review this weekend, and it took me a while to understand it. So it's okay if you don't understand it immediately. You just draw it out on paper and think about it, and then it will hopefully click like I did. I got it, so hopefully it clicks. And that's it. That's it. So next week we will start PA3, which, you know, it's with thread, but it's we reuse the server again, but yeah. And here's the meme about that, which, you know, we put about this, you know, my multi-thread programming with multiple threads would, you know, go crazy, and then, but in perfect example, it will always be so nicely orchestrated. So yeah, that's it. Do I still need to go over the background process, or everyone is good with that? Okay. So let me go over the last week. Let me pull it up from last week. So 5 my drive Sunday. Let's go. Actually, let me get this. So so we talk about the PA, the tokenizer class last week. We talk about converting command to our constant car so that you can put it into exec VP nicely. And then we have question, and let's go to good stuff, objective for next week, and blah, 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 blah. So again, you just do the hint I give you, which is this, then you can pass it in basic command, and that would be pretty simple. So let's talk about background process. So the goal of background processes is the terminal should not stall while executing the background process. We still do exec VP as normal, but the parent will not do wait PID on that child. And we must keep track of the child PID and occasionally check if the child is done so that we can clean it up. And I will show you in a bit in my code so that you can see. And then prevent zombie process. So if you don't check it and you don't kill it properly, you don't deallocate all the information, it will show in the process table and it will be a zombie process. So my solution is to make a vector of type PIDT. And then if the background process flag is true, instead of wait, right? Instead of you do like wait PID, you just push it the child to a PID, and that vector would hold it, and just a function that check complete. And I will show you. I give you the entire code, so you maybe that will be a huge hint. And you iterate through the table and check. So my terminal will check right after the command is executed, and your I think worker no hang or something W no hang flag is your best friend, because you can see that you don't hang when you check it. You just you just keep checking, and then if the status return greater than 0, that means the process is killed properly, and you just deallocate it from. I mean, you remove that entry from the vector, and you would. That's it. So let me show you. Oops. I will have to hide that, but that's okay. So in this case, I have the check background process right here that will check for the background. So every time you enter things, and howdy, every time you enter things, it would after you enter things. So let's do make all, and then if you do shell, and so if you do like let's say sleep 5, okay, let's wait 5 seconds. So it's sleep 5 seconds. So this is you have to do wait PID, right? You always have to do wait PID if you don't have. But if you do sleep 5 with the ampersand, well, it will just sleep, right? And then if I do sleep 1, so then you can see that after it's execute, right? After 5 seconds, it will go back to the top and it will do this. It will check if this process is done, then it will kill the PID. So it's quite actually not bad. So let me go. I need to hide this, but go to definition. Oh no, go to declaration. What the heck? Okay, I will have to zoom it up. So this will just check for the one that I just showed you, so that it check the status and then you just loop around that I explained. But you can see that in my simple processor, all I do is if parent process, if CMD is background, right, then you push it to the PID vector, and then else, if not, then you do the whole wait PID here. So that's it. It's very simple, and I think you should be able to do it. Actually, that's kind of embarrassing, but I just give you the thing. But yes, that's it. And you can also see in shell that I have a vector PIDT of PIDs. And that's it. Yep. Any other question? Yes, right here, right at the beginning of the for loop. Right at the beginning of the for loop, you check it, and then just I think sleep again, sleep 5. Let's do sleep 2, and do this, and then if you do, let's say ls L, and then you do grab command, and it would print it out and it would tell you that this PID is killed, and that's it. And does that make sense? I hope. Okay. Okay. Yeah. I sorry about that. Any other question I can help with? We have about 38 minutes, so it's a lot of time for questions and for anything that you need help with. Oh, no question. Question number 1, 2, 3. Okay, no question. So what? Okay, so let me ask this. Why are you here for something? Are you here just to see me do this, or you have any question that you want to ask, or private question that you want to ask? Mm. Mm. Okay. I just want. I think you weren't here last week. I just wanted to let you know again is that I don't have office hour after this. I only have this time. I have to remove some of the office hours to work on other stuff a little bit. So I won't have office hour after this. Sorry about that. But Ross will be here to help you for like I think from 3 to 4. So there's that. Yes. So any question? Yes. Yes. So that's the last part. Yes. So that is the pipe command, and I think once you do that, then you get all the checkpoints. Yep. So you again, I think I showed in here. Let me show you. Is it 2, 4? Okay. So where is it? Right here. So you just have to make a pipe. You just do FD2, right? You just have a file descriptor, two file descriptor array, and then you just plug it in the pipe command right here, and then that would create the pipe for you. Now you can use the pipe. You can use the file descriptor. It doesn't give you a pipe object. It just gives you two file descriptor that you can use, which are just two integers, so that you can use and plug it in things just like IO redirection kind of thing. Yep. Yep. I think yeah, it's pretty simple once you think about it. When I took this class, it took me a while to understand it, but so I try to pull out the things that I try to do, and I just make a summary of it so that you can hopefully understand it a little bit faster. I think there are also some bonuses like the signed extension. Now I won't cover that because I never did the bonus at all myself. Again, we did not have a tokenizer back then, so we spent a lot of time actually make a tokenizer. And there's also one about history, command history. So that one is quite actually not too bad. I think Zeke already mentioned some libraries that you can use for your function, and that would also you can store it in a file. Actually, the terminal, I think the official terminal use file, so it's stored in a file history in your main terminal and your main directory, and then you can tap up and it will go to previous command. So if you want to do the bonuses rather, then that's more power to you. Yep. Any other questions? Anything I need to? Yes. Oh, okay. Yes. So dupe. Okay. So dupe 2. Okay. So I think let me pull out the man page for dupe 2. So dupe. Okay. So dupe. Okay. And then lowest number. Okay. So it's just gonna be, so you see dupe will have old file descriptor, and the dupe 2 will have two parameters, old and new. So basically dupe, it just duplicate the file descriptor. So in this case, let me show you. So in this case, let's draw a file descriptor table. So the standard classic std out, std in rather. So that's 0, std out, and then std error. That's 2. So let's say you open a file. Let's call it min.txt. And that would have the 4, right? So let's say you want to create another file descriptor that is point to the same file descriptor as min.txt. So this one will point to a file named min. Okay. And I leave out the thing. Now, what dupe does, so if you do fd int fd equal to dupe, and let's do 4, right? If you do this, what it does is it's just gonna duplicate whatever this is, make a new one called, let's say, file descriptor 5, and it will point to the same one as 4. So if you modify, if you write, you can either write in 4 and write in 5, and it will write to the same file min, and you can read from the same thing as well. So like if you read from it, then both of them can be read from the same, read to the same file, write to the same file, and read from the same file. There you go. So that is dupe. So dupe 2, what it does is so let's say this one does, I think it does not return. Let me make sure it does not return. So I think I do have a dupe somewhere from the previous one. Okay, right here, dupe. So you can see it returned an int. So it duplicate FD to FD2, and then it closes closing FD2 and making it open to the same file. So in this case, if you do int, I think it's like FD, I think no, it returned an error code. So instead of returning the F file descriptor like the first one, what it does is return an error code. So status, so status equal to dupe 2. And let's say if you do, let's say the 4 and 5. So if you have, let's say standard in, okay? So if you, I think it's like, I think old and new. Is it old and new? Let me see. File descriptor. Sorry about that. Let me look at, make sure I'm looking at the right one. So it's old and new. Okay. So let's say if you do std in 0, and then you do 4, right? So what it does is instead of putting it into std, not 0, sorry. Let's do 1. Actually 0. Yeah, right. Instead of getting the input from standard input, what it does is it's gonna move this pointer from standard input and move it to the file. Okay, so it move it down to the file, and it closes the previous file descriptor. Closes the previous file descriptor. In this case, it's standard in. So if you do dupe 2 like this, the process will get the input from min.txt, and the standard input will be closed forever. So that means your standard input will be lost forever. So even if you type in 0 now, it doesn't work. It's still gonna give you, like, I think error, or give you something. I actually not sure, but it will be lost forever. So like it's gone. So this one will just duplicate, but this one duplicate and close the one, and that's it. Does that make sense? That's the right way to think about it. Yeah. So like, you know how in copy you do copy, paste, and then you delete the previous file. That's basically cut. Yeah. Mm-hmm. And then there's dupe 3, which I just learned, which is just another flag. So I assume it's something with the flags so that you can do it. But yeah, so again, dupe system call create a copy of the file descriptor old FD using the lowest numbered unused file descriptor. So again, the oldest, the lowest one is 5. So it used that and just duplicate it. And then I think for dupe 2, perform the same task as dupe, but instead of using lower numbered unused file descriptor, it uses the file descriptor number specified in new FD, right? And if the file descriptor new FD was previously open, it is silently closed before being reused. So it's closed. So in this case, if you move std in from standard output, from 0, file descriptor 0, from standard output as standard input, it moved down to min.txt, and they just close standard input. And your process basically have no input beside min.txt. Yep, that's it. So if I think it has to do with the fact that if you're going to close and open things in your parents, you have to be careful. So you have to make sure, I think you have to dupe so that you can make a copy of standard input, and then you can use standard input for something else. Like if you do dupe and then dupe 2, what it does is it's gonna make a copy of the standard input so that you can still have access to standard input after you use Duke 2 on the standard input file descriptor. And that's it. Okay. Any other question? Okay. I guess I'll make the recording available. I don't think if there's no other general question, you can start. I think that's it. I'm probably gonna if you have a private question or you need me, I will be here until 3, of course. So if you have anything, I would just make a new room that you can do office hour. I think that's it. So I will stop sharing. And I will flee its recording. Okay, so stop recording. Yes, thank you. Yes, you want